Okay, guys, so this video I'm going to be talking about how you can set up your own local smart contracts development setup and start developing smart contracts on your machine right now and also test them while you're at it. So the way I'm going to be doing this is with the help of a few tools. First is the Hardhat, which is nothing but a development environment for Ethereum software, which is basically nothing but with Hardhat you can compile, debug, and build Solidity smart contracts and deploy them to any chain that you would like once you feel that you're ready with it. And for doing all that, we will use VS Code as the text editor. And for testing your smart contracts, you can use Laika. I will show you how you can use that. Let's get into it. So for the first step, I know that I have told you that we will use Hardhat. So how you can do it is um, Hardhat is basically a npm.js package which you can use to create projects. So if you don't know, npm.js projects, npm.js packages can be used uh, in a Node.js project. So to use Hardhat, we will need to have a Node.js project. If you don't know what that is, you should probably have an idea about it. Mm, you can look up some tutorials on how you can create a Node.js project, and then you can continue this video. But if you already know how Node.js works, then this should be fairly easy for you. So if you don't know, what I did there was just I had some stuff over here in this directory. I emptied it, and now I'm going into it to showcase how you can create a Hardhat project inside of it. So here I have VS Code set up, and in the terminal you can see that I don't have any project yet. You can do yarn init y to create a new npm.js project, node.js project, sorry. This is the same as if you do node init. If you don't, I use yarn because it's a little bit faster for me. So once I do this yarn init y, you can see the package.json file was created with very basic details about this package. Now what I will do is add Hardhat to this project. Once I do this, what it will do is download the Hardhat plugin and download it to this project so that I can use this Hardhat CLI inside my project and build our smart contract with it. So you can see that it is downloading. As soon as it is finished downloading, you can see that Hardhat was added to our dependencies. Now I can do this npx Hardhat, and you can see that it will show up this kind of a setup where it gives me three options. I can basically create a JavaScript project, a TypeScript project, or an empty Hardhat project. Here we will just create a JavaScript project. Let's go through it. It will ask for me the project directory. I will choose the default one for now. Yes, and then what it will do is install all of the dependencies that it needs. While it is installing that, I'm going to show you how this directory structure looks like. Inside contracts will be all of your smart contracts. Inside scripts will be your scripts that you would use while developing the smart contract setup. Here you can see that there is only one script, deploy.js, which is basically for deploying this script to some network. Uh, then there is another directory called test, inside which there are test files, which by using you can test your smart contracts. Now in this tutorial, we are only going to be talking about contracts and scripts because I don't know much about how tests works for now. So let's just look into it. Yeah, the project installation has been done. So if you see the structure right now, we can see the package.json, and you can see that a lot of dev dependencies were added. So these are all necessary for any hard hat project to run. Okay, now if I do, uh, so with any program, uh, what you would need is like with any program, if you have developed any, you know that we need to compile if it is a compile language, or if it is an interpreted language, we do need to run the script. Here in this case, Solidity is a compiled language. So once you are once you have done once you have written your smart contracts, what you would need to do is first compile the smart contracts, and once it is compiled, you would need to deploy the compiled smart contract to any chain that you would like. So all of this can be done using our Hardhat plugin. So if you just do npx hardhat compile, you can see that it will compile our project. And if we do npx hardhat, uh, and if we run this scripts.deploy file, a script/deploy file, it will deploy it. But before deploying it, obviously you will not deploy your smart contracts directly to some chain. First, you would need to test it locally. So for testing it locally, you would need a local blockchain node with where you can deploy it and test basically all the functions if they work or not. So you can start a local node by typing out npx hardhat node. And once you do that, what it will do is spin up a local blockchain node with 20 different accounts. You can use these accounts to, it already has some ETH in it. So you can use this account to test your smart contracts. You wouldn't need a faucet in this case. Now, once you have this node set up, what you would need to do is deploy your smart contracts. So you can do that by doing npx hardhat run and then specifying the name of deploy function, deploy script. In our case, it is inside scripts slash deploy.js. While you do that, you also need to specify the network on which you are trying to deploy it. So in our case, it will be localhost. Um, Make sure that if you are deploying into some testnet or mainnet, you have the configuration written over here in hardhat.config.json. In our case, we are deploying it to localhost, so we don't need really a configuration. We can just specify localhost and it will do that. So if we do this command, you can see that it will try to deploy our smart contract. And in the logs, you can see that it did so. If you see our console in which the node was running, you can see that a transaction was sent here, and that transaction was for deploying a contract. The name of the contract is lock, and it was deployed on this address with the transaction hash of this, and this much of heat was locked in it, and it was on the block number this. So you already know how this is going. Now here comes the interesting part. You know how to create smart contract project, you know how to compile a smart contract, you know how to deploy it. Now for testing it, you would need something which is known as the smart contracts ABI, as well as the address at which it was deployed. So if you can, I don't know if you can find it in this or not. Let me just format this document real quick. So now this is a very huge file. I don't think so it exists over here. But if you look into this, yeah, you can see this contracts slash log.sol has a log.json file. This is nothing but the ABI for the file. So whenever we do need to test our smart contract, we would need this ABI file. Even when you are working on a front end project and you need to integrate this smart contract, you would need this ABI file inside your front end code to be able to access the smart contract and work with it. So here we have this ABI here, and as well as the deployment address over here, contract address over here. So we can start our testing right now. But if you didn't know, if you have like a front end project over here in this directory only, this with the Hardhat runtime environment, you can basically read an artifact, and this ABI is inside this artifact. So you can read this log.json artifact and export it to any directory you like, so that you had that ABI inside that directory. So that's just for letting you guys know. If you have that set up, and we have the ABI as well as the contract address, now we can use Laika to test our app. So we can start, we can go here at web.getlaika.app, and here we can create a new collection, and we can do this upload JSON ABI. And here we would need to specify two things. First, before we do that, make sure that you have MetaMask installed and you are on the network of Hardhat. If you don't have this Hardhat network inside your MetaMask account or MetaMask wallet, what I would recommend is go here, settings, networks, and then click on add network, and then here you can basically write Hardhat network. And Hardhat is usually runs on this 127.0.0.1, and the port is 8545. Once you do that, you can hit on save, and it will get added as a network. So make sure that you are on Hardhat network, and once you are on Hardhat network, what you can do is new upload JSON ABI. Select the contract address from VS Code. So it was deployed to this address. Put the contract address over here, and for the JSON file, what you can do is basically go to Hardhat local and set up. This was our project. Inside artifacts, inside contracts, inside log.sol, we have log.json. You can use that. You can click on import, and you can see that we have three functions over here. So if I just do, okay, let me just click on connect MetaMask, and yep, it has connected. If I do send, you can see that it's responding with the log time. If I do send, you can see that it's responding the owner address. I can show you that it's the correct address by, just see the value. It's like OXF39FD. And if you see here in our node, this is basically the first account, OXF39FD60. So that is it. um you can do this basically with any smart contract. So whenever you do write a smart contract over here, you would need to include the deployment file, sorry, the deployment code inside deploy.js, or basically create a new script in which you write the code to deploy that contract. Here you can see the code for deploying that smart contract was very easy. What it did was got the current timestamp. uh, it calculated how many seconds that there are in a year, and it basically set the unlock time as current timestamp plus how many seconds are there in a year. And it got the contract factory using Hardhat runtime environment, and it basically deployed this contract factory with the unlock time and the amount of ether, that is 1 ether. And it waited till it was deployed and then printed out this message, which is this here that we see. So that is basically how you can set up a local environment and test it using Laika app. Like the video if you found it helpful, and I'll see you in the next one.